guys, we're doing chapter 4, section 2 today. We're just talking about rationals like we did yesterday. Yesterday we found all the stuff, the mechanics behind it. Now we're going to actually graph. Now when I do this with pre-cal, I worked all the examples out yesterday. It took me almost 2 hours to do all these examples. The hardest part of that is finding additional points because I make them plug it in by hand and not use a calculator. Ms. Ferrier's like, oh no, we let the kids use the calculator. It took me about 3 seconds. So the hard part that I think that it's not hard, it's just tedious. You guys are going to be able to use your calculator, so it's not that bad. So this first slide, I already wrote some notes on it. I want you guys to go ahead. I'll zoom in on it so you can see. But we're going to go through all of these things on how to mechanically find what we're looking for you to do on the quiz. And then I'm going to show you how to graph it on the calculator. So go ahead and copy all this stuff down. All right, guys, so let's go through this list again. You are going to, by hand, show me all of this stuff, and then we're going to graph. And the graphing part is what we're going to spend probably the most time talking about, just to make sure you guys know how to do it. But the first thing you should do when you have a rational expression, first of all, rational, just a grown-up fraction, you want to simplify your expression to check for holes. How do we do that? We factor. If you have something on the top and the bottom, numerator and denominator, that is exactly the same, that's where your hole occurs. All right, remember that from yesterday? All right, then we're going to talk about asymptotes. Vertical asymptotes, horizontal, and slant. First of all, the vertical asymptote. We did not talk about domain yesterday. I did that on purpose. I wanted to wait till today. But vertical asymptotes and domain go hand in hand. I'll show you what I mean in a second. But what is really, really important to understand about the vertical asymptote and the graph? The graph is never going to do what? Touch. Never, ever, ever going to cross the vertical. It can cross the other two, but it will never cross the vertical. And the reason why is because at that specific point on the x-axis is where the denominator is what number? 0. So in your calculator, when you look at the table, you'll see in a second, it'll say error. That's where your asymptote is. It's undefined. So how do you find the vertical? You set the denominator equal to 0, right? How do you find the horizontal? Horizontal is going to be a y equals. How do we find that? We compare what? The degrees of the numerator and the denominator. If it's greater, something happens. If it's the same, something happens. If it's less, then something happens. And how do we find slant asymptotes? What do we use mechanically? Long division. If you have a horizontal asymptote, do you have a slant asymptote? No. If you do not have a horizontal, do you have a slant asymptote? Yes. And how do we answer slant asymptote? It should be in what kind of an answer? It's y equals mx plus b. If I have a remainder when I do my long division, do I include it? No. So your vertical asymptotes are always going to be x equals, and your horizontal asymptote, or as I lovingly call them, your it's y equals, right? Okay. To find the zeros, to find the x-intercepts, you set the numerator equal to 0, just the numerator. To find the y-intercepts, you find f of 0. You plug in 0 for all of the x's and solve it. And then we're going to talk about picking points and graphing, okay? So let's move along to number 1. I put a little list of all the stuff that you're going to need to find. VA is vertical asymptote. HA is horizontal, slant, holes, domain, x and y-intercepts, yeah? All right, so let's go through this. And I'm going to show you why vertical asymptote and domain go hand in hand, because domain is what axis? X, right? So domain is what are all the x values that can be used. Your vertical asymptote is the 1 or 2 values that can't be used, so they go together. So guys, how do we find the vertical asymptote? What am I going to do? Set the denominator equal to what? 0. So x equals 2. I have a vertical asymptote at x equals what number? So I would write x equals 2. How did I know what that is? I just showed you right here. So let's talk about the domain. What is the only value on the x-axis that cannot be used? 2. So what would my domain be? Negative infinity to 2. Parenthesis or bracket. Parenthesis. Why is it a parenthesis? Cannot include it. Good. Union, then what? 2 to infinity. What we like to say is domain is all the stuff the vertical asymptote isn't. You see what I'm saying? Vertical asymptotes are the only thing x can't be. Domain is everything x can be. They always go hand in hand. So now let's talk about our horizontal asymptote. How do we find our horizontal asymptote? We compare the what to the what? Numerator to the denominator. Remember, if you have just a constant, this is x to the 0 power. This is x to the first. So what is the degree of the numerator? 0. What's the degree of the denominator? 1. 0 is what than 1? Less than. Look at your little cheat sheet from yesterday. I would put it next to every problem we do. If the numerator degree is less than, what's our horizontal asymptote? 0. At what 0? Y equals 0. I can assure you guys, if you do not put y equals and x equals, you'll get points off. Since I have a horizontal asymptote, what do I know about my slant? There's none. Was there any holes in this problem? No, nothing. That was the same on top and bottom. Good. So now we find x and y intercepts. How do we find the x-intercept? We set the numerator, what? Equal to 0. So 3 equals 0. Is that possible? No. So what's my x-intercept? No. There isn't one. Good. There's no x-intercept. This does not cross. Very good. And then how do you find the y? Denominator? Not denominator. Look at your cheat sheet. We talked about it earlier. Just a few minutes ago. How do you find the y-intercept? F of what? 0. So take your function, 3 over 0 minus 2. What does this become? Negative 3/2. So when you plug in 0 for x, you get out what? Negative 3 over 2. Now, what you guys need to do is plot the stuff you know. We know our vertical asymptote is at x equals 2. So I'm going to draw a dashed or dotted line. It's broken. It is not a solid line, guys, because it's a boundary. It's not a physical line. My second asymptote that I'm going to draw is at y equals 0, correct? So we always draw our asymptotes, and then we always plot our intercepts. Do I have an x-intercept? No. Do I have a y-intercept? Yes. At where? 0, negative 3/2. So about there. Now in pre-cal, I would say, okay, guys, now we're going to pick points. I want you to pick 2 points to the left of the vertical asymptote and then 2 to the right. And you plug into your equation and you say, okay, what does my curve look like? We are not going to do that. We are actually going to use our calculator. So everybody, calculator. If you have that N over D button, like I just said, you can use it. If not, I'll tell you another thing to do. But go ahead and hit y equals, and then alpha y equals. That N over D should come up, yes? Now, does your calculator display look like this? Yeah? No. Okay, hold on. So now, guys, do you see how your calculator is letting you plug in a fraction? So go ahead and plug in your original. It's 3, and then just hit the down arrow, and then x minus 2. Okay, hit the 3. All right, so once we do that, guys, hit graph. And your nice little curve, perfect. You guys should have like 2 little boomerang-looking things, right? Okay, now that you guys have your little boomerangs, I want you to look at the top. Do you see where it says table? So I'm going to have to hit second table. And notice what comes up. What is your, my x is 0, what is your y value? Negative 3/2. If x is 1, what's your y value? Negative 3. If x is 2, what's your y value? Why does it say error? Because that's your asymptote, right? That's where it does not exist. So you're going to be asked, one second, Hannah. You're going to be asked to give additional points. I want additional points, 2 to the left of the vertical asymptote and 2 to the right. I don't care which ones you pick. I'm going to go ahead and say, all right, I'm going to plot, and I'm going to say 0 and negative 3/2, and I'm also going to plot 1 and negative 3. Right? 1 and negative 3. So I'm going to say 0 and negative 3/2. 0. Oh, never mind. I'm not going to do that one because that's my what? That's my intercept. So negative 1, negative 1. So negative 1, negative 1. And then I have positive 1, negative 3. 1, 2, 3. Do you see how this gives you the look of what your curve looks like? So now you guys can draw it. And then I'm going to pick 2 points to the right of the asymptote. So I'm just going to go ahead and pick 5 and 6. What's your y value when x is 5? 1. Okay, good. And what's your y value when x is 6? 3/4. Okay. So 1, 2, 3, 4, 5, 1. And then where x is 6, I'm at 3/4. So something like that. So where does my curve exist? It's going to be up here. But you guys already see where your curve exists because you graphed it on your calculator. Yes? Does that make sense? Okay, we're going to practice this a bunch. Natalie, let me help you in 1 second. You with me? Go to the y equals. So get it to say y equals. So plug in. You want to put your numerator in parentheses. So 3, parentheses, then hit divided by, and it'll put like the slash, and then in parentheses x minus 2. Same exact thing. You just want to put your numerator in parentheses. Get in the habit of that. You don't have to because it's just a single number. But when we get to more, in-depth questions, it's going to be easier to do that. So numerator, parenthesis, then hit divided by, and then the denominator, and then go. All right, let's look at the next one. Again, we're going to find all the stuff. We're going to go through this a little quicker. First of all, can I factor anything here? No. So I know right away what's the answer to my holes question? None. There's no holes. All right, so let's go through. Let's find our vertical asymptote. Remind me again, how do we find vertical asymptote? Denominator equal to? So x equals 0. Well, that was easy. So what's my vertical asymptote? X equals 0. Vertical asymptote goes hand in hand with what? Domain. The only thing x can't be is 0, so it can be everything else. How do I write that? Negative infinity to 0. Good. Yep. Perfect. All right, horizontal asymptote. Horizontal asymptote. We compare the numerator degree to the denominator degree. What is the numerator degree? 1. What's the highest exponent you see? 1. What's the denominator degree? 1. 1 is what to 1? Equal to. So that means my horizontal asymptote is that y equals the leading coefficient of the numerator over the leading coefficient of the denominator. So it's y equals what? Perfect. If we have a horizontal, what do we know we don't have? A slant, so there's none, no, nope, nada, whatever. Remind me again, how do I find an x-intercept? Numerator equal to 0. So 2x equals 1, x equals 1/2. How do we write intercepts, guys?
Like ordered.
Yep, ordered pair. So 1/2 comma what? 0. And then how do I find if I have a y-intercept? Plug in 0. So it's f of 0. So I take the whole thing and I say 2 times 0 minus 1 over 0. So negative 1 over 0. Huh?
Imaginary.
It's not imaginary. It's just what? Undefined. I don't have one. So your answer here would be none. I know that you guys can look at it, oh, it's going to be 0. I want to see. You got to support your work. So now what do we plot? Before we throw this in our calculator, what do we plot? What do we write on our graph? Okay, y-intercept, that's fine. Okay. Vertical and horizontal. I would do that first. So my vertical is at 0. It's right here. My horizontal is at y equals 2, so it's here. And then any intercepts we have, that helps out a lot. So where is my intercept? At x, what's my x-intercept? 1/2 comma 0, so it's like here-ish. Now I need to put this in my calculator and figure out what it looks like. So I'm going to go to my y equals. You can clear it out or you can just erase what's there, but I'm going to hit y equals, I'm going to hit alpha, y equals again, then an n over d comes up. And I put 2x minus 1. Natalie, this is where you need to make sure you're in parentheses. So 2x minus 1, then arrow down, and then put over x. And then hit graph. And it should look like it has exactly like where your asymptotes are. Then I want 2 additional points. So I want 2 points to the left of x equals 0. And I want 2 points to the right. So I'm going to hit second table. And if I go to the left of 0, I'm going to pick, again, you can pick whatever you want, but I'm going to pick -4 and -2. You guys tell me, what is the y value at -4? 9/4. Perfect. Excuse me? So then what happens at -2? What's my point? 5/2. Great, Mia. So let's go ahead and plot those.
I have a question. So do you just choose like any point?
Anything, any 2 to the left and 2 to the right on the x-axis. Left of the vertical asymptote and to the right.
And the vertical asymptote is 0.
In pink. So I'm going to go -4. 1, 2, 3, 4, and 9/4. 9/4 is above or below that horizontal asymptote. It's above. Good. And then -2. 1, 2. And then 5/2. Where's 5/2? It's 2.5, so it's above as well. All right. So again, you should be able to refer to your calculator to see, but you know it's like this. All right. Should my boomerang that I draw ever cross the x-axis? Or I'm sorry, the vertical asymptote? No. So make sure you don't. All right. So now let's pick 2 points to the right. How about 1 and I don't know, 5. What is my y? Hang on, Hannah. What is my y value at 1? 1. Good. And what is my y value at 5? 9/5. Perfect, guys. So I'm going to go to 1, 1. And then 1, 2, 3, 4. Where is 9/5? Just below 2, right? Again, you can check your graph and then just go like something like this. Hannah, question. All right, let's move along. You guys are great. Woo! We're going to do 2 more, I think. Is that what I have? Yeah, 2 more. We're going to get through this before the end. Again, the more you do this, it kind of gets a little easier. You guys are like, oh, if I like to go in this same order so that I don't make any mistakes or anything like that. But what do you notice about this problem? What can we do? We can factor. Let's go ahead and do that. I'm going to rewrite my numerator. And then what can I factor the bottom into? -2. Perfect. Perfect. All right. Now, does that help me in terms of do I have holes or not? Yes, because you can see you clearly yes or don't have holes. No. Nothing is exactly the same on the top and bottom. But this does show us that I have how many vertical asymptotes? Here I have 2. For my vertical asymptotes, I'm going to set both of these equal to 0. So my vertical asymptote, there's going to be one at x minus 2 equals 0. And there's going to be one at x plus 1 equals 0. Great color choice. So where are my 2 asymptotes? At x equals 2 and x equals, perfect. So my vertical asymptotes are at x equals 2 and x equals -1. So think about this, guys, because vertical asymptote and domain, correct, go hand in hand. I can use any number on the x-axis except for which 2? -1 and +2. How can I say that? Negative infinity to -1. Okay. Yep. -1 to 2. Perfect. And then 2 to infinity. Very good. Anybody have any questions on that? Good job, Frank. Okay, let's talk about our, excuse me, let's talk about our horizontal asymptote. How do we find horizontal asymptotes? We compare our numerator degree to the denominator. What is the degree of the numerator? 1. What's the degree of the denominator? 2. 2 is what? 1 is what than 2? Less than, I said it backwards. 1 is less than 2. So when your numerator degree is less than the denominator, what's your horizontal asymptote? What equals 0? Y equals 0. Awesome. Since we just discovered that we have a horizontal asymptote, what do we know we don't have? We don't have a slant. Good. Now remind me again, 2 more things. How do I find the x-intercept? Numerator equal to 0. So x equals 0. Well, that's easy. How do I write that as an intercept? 0, 0. Perfect. And then how do I find my y-intercept? F of 0. So I'm going to take this function. So I have 0 over. Don't tell me, oh, I already know it's 0. Show me 0 squared minus 0 minus 2. So when I simplify this, I get 0 over negative 2, which is what? Not undefined, it's what? 0. So my intercept here is at 0, 0. 0 on the top gives me 0. 0 on the bottom gives me undefined. All right, let's plot. I have two vertical asymptotes, one at 2 and one where? At negative 1, good. So my graph is going to look a little different. And again, if you had to do this by hand, like my poor pre-calc kids, they have lots of points to find in the middle here. Because there's actually going to be 3 sections, but you have your calculators. So what is my horizontal asymptote? Right here at 0. And I have color pencils, guys. I bought like 1,000 color pencils just for this section when I teach it in pre-cal. I will have them here for you guys to use. Because I know sometimes it's a lot easier to see. All right, so let's plot our intercepts. Where do I know this graph is going to cross? At 0. Are we allowed to cross horizontal asymptotes? Yep. Can we cross vertical ones? No. So here is where, do you guys see you have 2 vertical asymptotes? One in red, one in blue. So we're going to have to pick more than just 2 points. I need a couple points to the left of red. I need to the couple points to the right of blue. And then where else do I need some points? In the middle, in between. So let's go ahead and graph this. Let's throw it in our calculator. So hit alpha y equals, and then our n over d. And you can put your fraction. You have x in the numerator, and then underneath you have x, hit the squared button, minus x, minus 2. Hit your graph. You see how in the middle there's like a snaky looking thing? So this one looks a little different, yes? You have like a boomerang thing on the left, then a snaky thing in the middle, then a boomerang thing on the right? Yes or no, guys? Yeah. Okay. So let's pick some points to the left of my first, what's pretty? Not really anything. Let's go with negative 4 and negative 2. Try to pick the ones that are a little easy. Negative 4 and negative 2. What is the y value at negative 4? Negative 2/9. Okay, and then what's the y value at negative 2? Negative 1/2. All right, we can plot those. So negative 4, 1, 2, 3, 4. Negative 2/9 is just below 0. And then negative 2, 1, 2, and then 1/2. So here. And again, you can check your calculator and see, oh yeah, that makes sense. This is where the boomerang exists. Everybody with me? Okay, now I'm going to go in the middle. How can I tell on my table where the asymptotes are? Without looking at the graph. How can I tell on my table where the asymptotes are? It says error for the y. Yeah. So I'm going to plot a point where we already have one at 0, 0. That's fine. And then what's another point? 1 and? Okay, negative 1/2. What's another one? Do you see anything else in there? Yes or no? No? Okay, that's okay. Then go ahead. You can look back at your graph and kind of see what this looks like. Now, guys, when you draw this in the middle, what should you be very careful not to do? Don't touch the vertical asymptotes. It will not cross the vertical asymptote. And then I'm going to go back to my table, and I'm going to find 2 points to the right. Pick whatever you want. I'm going to say, how about 3? And 3 and 4 is good. What's my y value where x is 3? 3/4, great. What's my y value where x is 4? 2/5, good. So 3, 1, 2, 3, and 3/4. That's going to be above. And then at 4, I'm still above. And if you need to go back to your table to look and say, oh, yep, I did it right. Here it is. It's up here. How are we doing? This is so much easier with calculator. Everybody okay? All right, I want to do one more. It's a little bit different, and then we'll finish up the examples tomorrow, and I'll go over any questions you had on the web assign or stuff that you might have from tonight. Let's go to the next one. What do we notice about this one? You can factor. Right away we can go, oh, wait a second, we can factor. So let's go ahead and do that, okay? What can I factor the numerator into? X plus 3 and x minus 3. Perfect. What about the denominator? I have x minus 3 and x plus 1. Why is it so important to factor first? What did you guys just find? There's a hole. Do you see how you have x minus 3 on the top and the bottom? Go ahead and cross it out. That is where your hole occurs. So I'm going to say, okay, my hole. You take x minus 3, set equal to 0, where you get x equals what? 3. So if I know that x equals 3, how do I figure out what the y part of the hole is? You plug it into what? The simplified. You plug it into what you've already factored. So I'm going to say, okay, well, I'm going to say 3 plus 3 over 3 plus 1. What's 3 plus 3? 6 over 4, which becomes 3 over 2. So I have a hole in my graph at 3 comma 3 over 2. I'll show you what that looks like in a second. Very important. Now, guys, why is that also important? Because if you wouldn't have done the hole first, you would have told me there was how many vertical asymptotes? 2, but there's not. There's really what?
1.
Just 1. What is the vertical asymptote? Where? Right? X plus 1 equals 0, so your vertical asymptote is at negative 1. So let's talk about this. X equals negative 1. Your vertical asymptote and your domain go hand in hand, correct? What's my domain? Okay, negative infinity to negative 1. Union. All right, you want to say negative 1 to infinity? Okay. We might revisit it. We might not. We'll see. How do you find the horizontal asymptote again? Compare numerator and denominator. It doesn't matter which one you compare, guys. If you want to go to the original, it's 2 and 2, right? If you want to go to the simplified one, it's 1 and 1. But they both are what to each other? Equal to. So we take the leading coefficient of the numerator and the leading coefficient of the denominator, and what does that give me? Y equals 1. Great. The number in front of x squared or the number in front of x? All right. If I have a horizontal, what do I know I don't have? Perfect. X-intercepts, remind me again. What do I do? X-intercept, what equal to 0? The numerator. So x squared. Oh, we always go back to the simplified, sorry, because we've accounted for the hole, right? Because obviously it's not going to cross where a hole exists. So go back to the simplified for your intercept. So I have x plus 3 equals 0. So where's this going to cross? Negative 3. So my intercept is at negative 3 comma what? Good. And then we're going to go back to find our y-intercept. Go to your simplified, because we've already taken our hole out. So I'm going to plug in 0. 0 plus 3 over 0 plus 1 gives me what? 3 over 1. So my y-intercept is that when I plug in 0, I get positive 3. Everybody with me? All right, so let's plot everything. I have a vertical asymptote at negative 1. I have an x-intercept at negative 3, 0. I have a y-intercept at 0, 3. And what else do I have that I need to account for? Okay, the hole. And I also have a my horizontal, right? Where is my hole? What is the value of the hole? 3 comma what?
3 over 2.
Yeah, 3 comma 3 over 2. So we can go over here, guys, to that point. We can go 1, 2, 3, and 3 over 2. And I want you to put an open circle. Why am I putting an open circle? What does that mean? Okay, why though? Why is it open and not closed? Because it's not included. Perfect. So let's go to our calculator, please. Once we're done with this, we're done. You guys are doing great. Hit alpha, y equals your n over d, and let's put this fraction in. X squared. You okay? Okay, x squared minus 9, then arrow down. You have x squared minus 2x minus 3. And let's hit graph. Now, on your calculator, can you visibly see the hole? The way that your window is set right now. Can you guys see it? Is anybody here? Can you guys see the hole? No, I can't see it. I mean, I don't. It's because you're so far zoomed out. But if you hit the table, and you go to look and you say, okay, well, wait a second. What do you notice is in your y equals column? How many errors do you see? Okay, 1 second. How many errors do you see in the table?
2.
I see 2. Does our domain tell me that I have 2 errors? No. My domain tells me I only have how many errors? 1. If you guys forget or you get a little confused with the domain when there's a hole, you can always look at your table. What is my domain? How do I say I can use all of the numbers that I have represented, but 3 is a problem, just 3? Well, how do I write that? I can write negative infinity to what? To negative 1, correct? You guys agree? Okay, then where can I use? Negative 1 to what? 3. Then where? 3 to infinity. When you have a hole, guys, you have to account for that in your domain. If you forget that, if you're like, oh man, that's okay, because you can fix it. You can find it when you go to your table. Because what does the word error mean? When you have an x value, but it says error for y. What does that mean? There's an asymptote or there's a hole. There's a problem. So now let's go ahead and pick some points. Let's go back, look at our graph. Let's see. Okay, let's pick some points to the left and to the right. So I'll do this quick. I'm going to say negative 5 is what? 1/2. So 1, 2, 3, 4. That's fine because we already have the intercept over there. And then on the right-hand side, what's 1? 1, 2, and then what's 7? Okay, so at 1, I'm at 2. And at 7, 1, 2, 3, 4, 5, 6, I'm at 5, 4. So when I draw this, guys, watch. I'm going to come here, I'm going to come down, and then I'm going to touch the hole. Do I go through the hole? No, go to the other side, but make sure I can see. Ooh, you understand there is a hole. It's an open spot on the graph. What do I have at either ends of my boomerangs? Arrows. Make sure you have that.